Unit 4, again, was on rational functions, essentially fractions. So let's talk about just straight up reducing them to begin with. So 3x minus 15 over 5 minus x. I cannot cancel out anything yet because I have to factor it first. Anything that's a part of a subtraction or an addition, I cannot cancel out just a part of that. It's got to be the whole thing. So looking at the top, 3x minus 15, I can take a 3 out of that. What's left inside when I take that 3 out? X minus 5 is exactly right. On the bottom, that looks an awful lot like x minus 5, but the signs are switched. It's in the wrong order. Take a negative out. Negative out leaves us with that same x minus 5 that we want. The negative x becomes positive. Positive 5 becomes negative. Now that I have the exact same factor on the top and the bottom, that reduces down to 1. So the x minus 5 over x minus 5 reduces to 1, and I am left with 3 over negative 1, or just negative 3. There is my reduced or simplified expression. However, it does ask us to state excluded values. An excluded value would be anything that would make us divide by 0, which means going back here before I simplified and looking at the factors and saying what would make each one 0. Well, x equals 5 would make this 0. But instead of writing x equals 5, like when we were doing x-intercepts on Unit 3, we say x cannot be 5 because that would make me divide by 0. Does that idea make sense to everyone? Simplifying, stating excluded values. So then for number 2, we're going to factor top and bottom. Don't cancel anything until you factored. The top looks like I could take out an x from both of those, leaving me with x times x minus 2. The bottom, what two numbers multiply to 10 but add to 7? 2 and 5. But in order for it to be a negative 7, what am I going to have to do? Both of them negative. Is everybody good with that? So x minus 2, over x minus 2, x minus 5. Now, this is actually the best time to check for excluded values. You can always come back to this step if you forget about it, which I often do. But while we're paused here, let's just say what would make me divide by 0. What are the two numbers that x cannot be? Be careful. Positive 2 and positive 5, right? Because those are the two that would make me divide by 0. X cannot be 2, x cannot be 5. Do I have any factors that are exactly the same on the top and bottom? The x minus 2's. Those reduce down to 1. I'm left with just x over x minus 5. Can I reduce the x's? No, because this bottom one is a part of the x minus 5. If you want to leave it in parentheses to remind yourself that that is one piece, go for it. That's a good way of keeping track of the fact that this has to stay together. Let's try number 4. The very top part is factoring by grouping. The bottom is going to be guess and check or area method. I want you guys to try the top at least. I'm going to give you 2 minutes to factor that top part to get some practice with factoring by grouping. After that 2 minutes, we'll go over it. The bottom part, if you finish quickly, you could try the bottom. We'll work out the bottom part together if we need to. So everybody try the top, factoring by grouping. Check the first two, what do they have in common? Second two, what do they have in common? Factor it all the way if you can. If you're stuck, check with somebody nearby, or raise your hand and check with me. All right, let's try this top one. X cubed, 3x squared, minus x minus 3. I need factors from the first two terms. What do they have in common? Emily, why? X squared. Take that x squared out. But then what is left over? Dom, when I take an x squared out of both of those, what's left over here? X and a positive 3. Now for the next one, negative x minus 3. What do those two have in common? Jaime, what do you think? This one's a little interesting. Yeah, they both have a negative, so I can take a negative 1 out. And if we did it right, if everything's lining up, this should be x plus 3. Is everybody good with that? So now, take those x plus 3's and factor them out. X plus 3 times x squared minus 1. X squared times x plus 3, negative 1 times x plus 3. Does that make sense to everybody? This then is going to factor again. The x plus 3 is good, but the x squared minus 1, again, I haven't done a proof to make sure it's 100% of the time, but pretty much every time we do a factoring by grouping, this ends up being a difference of squares. I bet you could have ones where it's not a difference of squares, but it would be x squared like minus a number that doesn't actually have a perfect square. We just almost always give you ones that are a difference of squares so that it factors one more time. And what is that one more time? X squared minus 1. Bianca, can you tell me what x squared minus 1 factors into? And if you want a hint, the idea is I need two numbers that multiply to make 1. What's the only way to multiply to make 1? So we are going to have an x minus 1, but then it is x plus 1. And again, the reason this works is 1 times 1 still makes 1, but I get a negative at 1x and a positive 1x, and those add up to 0 in the middle. That's why there's no middle term for that one. Anytime we have x squared minus something squared, it's going to be x minus the something, x plus the something for that difference of squares. So there's the top, factored with factoring by grouping. Now I need to deal with the bottom. 2x squared plus 5x minus 3. This one, probably easiest to factor by grouping. Or sorry, not by grouping. Factoring using either guess and check or the area method. So I'm going to show you the area method again. I'm looking for numbers. They need to multiply. We need a 2x squared here, and we need a negative 3 down here, and these two need to add up to 5x. So the only way to get that 2x squared, 2x and x, but now I need numbers that multiply to negative 3. What are my options? 3 and 1, 1 and 3. And then one of them is going to be negative, one of them is going to be positive to make that a negative 3. So really I have 4 options. I can do a 1 or a 3 here, a 1 or a 3 here, and one of them's positive, one of them's negative. So let's try something. Let's go ahead and let's do the plus 3 up here, the minus 1 here. That's going to multiply to make negative 3. But if I multiply that out, x times 3 gets me 3x, 2 times negative 1, negative 1x, negative 2x. Negative 1 times 2 is negative 2x. That, well, we see the 3 and the 2 and we're like, oh, that might add up to 5. But because one of them is going to be positive, one of them is going to be negative, this is not going to work. I'm going to get 1x, and there's no way for me to make it work by switching signs, right? If I switch the signs, I'll just get a positive or negative 1x. And I can't make this one positive and this one positive, because then this isn't negative 3 anymore. So let's try switching the places. Put the 3 down here. So plus 3, and minus 1. Hopefully that's showing up on the videos. Okay, there we go. 1 times, negative 1 times x would be negative 1x. 2 times 3 is going to be 6x. That looks better. 6x minus 1x does give me my 5x that I wanted. Does that make sense to everybody? So now, those are my factors. 2x minus 1 and x plus 3. This is, again, a great time to check for excluded values. This one I think most of us are good with. X cannot be negative 3, right? X plus 3, can't put negative 3 in there. If you're still having trouble identifying what would make 2x minus 1 0, set it equal to 0 and solve. 2x minus 1 equals 0. Add 1 to both sides. Two x equals 1. Divide by 2. X equals 1/2. So x cannot be 1/2 because that would make me divide by 0. Right now then, I have the top divided by 2x minus 1 times x plus 3. Is there anything that simplifies here? Here are a few of you noticing it. We've got x plus 3's on the top and bottom. Those would reduce to 1. And I'd be left with x minus 1 times x plus 1 over 2x minus 1. There's my reduced fraction. Here are my excluded values. Let's skip 3, okay, guys? You can just cross out 3. Don't worry about that one at all. Let's look instead down here at 5. 5 has similar ideas, but you've got a multiplication here. With this, you're going to factor everything. Factor all 4 terms. Make it all one big fraction, right? Multiplication, top times top, bottom times bottom. You'll have a bunch of factors on the top, bunch of factors on the bottom. Anything that shows up top and bottom, you can simplify. I'm going to give you 2 minutes to start factoring all of this. Then we'll come back. I'll call on 4 people. You can pick which one you want to factor. We'll reduce it. So again, 2 minutes to factor those 4 expressions on number 5. Go ahead and go. Where did I put my pen? All right, let's see how we did. I'm going to call in 4 people. You guys can pick which one you want to factor here. Joey, which of these 4 do you want to factor? Okay, guys, go ahead. Okay, and what does that factor into? Okay, if that was the case, it would be a difference of squares. And -2 times +2 would be -4. Yeah, both of them x minus 2. There we go. Does that make sense to everybody? So we've got this one factored. Let's pick another one. Ednan, which of the other 3 do you want to factor? Okay, what does that factor into? Perfect. X minus 5, x plus 2, that multiplies to -10, adds up to -3. Now, hopefully, everybody was good with these two. These are just greatest common factor. What do they have in common? So, LJ, can you factor one of those two for us? Okay. Yeah, take that 4 out, and then what's left over? Minus what? X minus 2. Is everybody good there? 4 times x is 4x. 4 times -2 is the -8. So that one's factored, and I essentially have 4 factors on the top. X minus 5, x plus 2, 4, and x minus 2. Almost ready here. Let's do the bottom now. Dom, how do I factor that 2x minus 10? Yep. X minus 5. There we go. Everything's factored. Now, one of the students in the last period asked, what about the excluded values? This one doesn't actually ask you to do that, okay? If you wanted to practice that, you're more than welcome to state the excluded values for anything that's ever on the bottom of the fraction, but we don't have to worry about that right now. We just need to reduce it. So what do we see that's on the top and the bottom? Let's see. Not here today. Kaiva. So the x. So we're looking for something that's on the top and the bottom. Do you see something that's on the top and the bottom? X minus 2. So let's take one of those. One of those. There's still an x minus 2 left over, right? Does that make sense to everybody? But what else? Is there anything else that simplifies? Johnson. X minus 5s reduce. to 1. Now we're real close, but are we done? There's one more thing that reduces. I'll take a volunteer for the last one. Go for it. The 4 and the 2, right? Just like a fraction. 4 over 2 reduces. We end up with a 2 here and a 1 down there. So my final answer here is 2x plus 2 over 1x minus 2. There's my final answer. Is everybody good there? And that's what it's going to look like on the final. As far as you're picking one of the 4 answers, one of them is going to look like that. So now, I want you guys to try 6. Same thing, but we have one extra step at the beginning. Division becomes multiplication, 2x squared minus 18. The first one does not change, x squared minus x minus 2. But this division becomes multiplication times this one flipped over. The whole keep, change, flip, giving us x squared plus x minus 6 over 10x minus 30. I want you guys to try that one. Same operations here. Go ahead and factor it, simplify it, and then we'll come back and I'll call on 4 people to help us simplify that. All right, let's go ahead and factor these. I know some of you are still working, keep going. Others are already done. So, let's pick the first one. Julian, give me one of those 4 that you want to factor. Okay, how do we factor that? Okay, 2 comes out. Okay, x squared minus 9. So, this is good. This is the first step. This one factors more, though. So I'm going to have somebody else, I'll take a volunteer. Who wants to finish factoring that one? Go for it.
2 times x minus 8 x plus 3.
Right, that's a difference of squares. So we want to break that all the way up. Does that make sense to everybody? You do have to do the first step that Julian did of taking that 2 out, or else it's not a difference of squares yet. Yeah.
Did you choose what's it called? Not
The area method?
Yeah.
So, I am glad you brought that up. I've been wondering whether I should show you guys that or not. It will work. If you use the area method on this one, back up here. The 2x squared minus 18. You can do that saying, okay, I need this to be 2x squared and negative 18. This is 2x. This is x. This would end up being essentially a 6 and a 3. And you'd have to make sure that they were opposite. So I think it ends up being a 2x minus 6 and an x plus 3. In fact, you might even be able to do it the other way too. You might be able to do a plus 3 up here and a minus 3 down here. And it'll work either way. Because you get 2x times 3 is 6x. 6 times x is negative 6x. These add up to 0. The trick is, if you do it this way, you're left with that 2x minus 6 times x plus 3, or 2x plus 3, or plus 6, x minus 3. And this one is going to factor again, because it's got a greatest common factor of 2. So eventually, you'll get the same answer. Does that make sense? It will work just fine like that. Just a different way. Let's get the other ones factored now. So Ethan Rocca, pick another one that you want to factor. I know you just did the last one for volunteer, but go ahead and do another one. 10x minus 30. What do you do with that one? And what's left over? Yep, 10 times x minus 3. All right, we've got 2 left. Ethan Bravo, you want to pick one of them?
Yeah, sure. I'll take the bottom one.
Okay. How does that factor?
Yeah. It just goes x plus 1 and x minus 2.
X plus 1, x minus 2. That gets us again the negative 2 when we multiply, negative 1x when we add them together. Almost done. We've got 1 left over. Nathan Sanchez, how do we factor x squared plus x minus 6?
What do you do? X plus 2, x minus
Okay, that's really close. It is x and 2 and x and 3, but if, yeah, switch the signs so that we end up with that positive x. Does that make sense?
Yeah.
So a minus on the 2, a plus on the 3. And now it's all factored. We're now looking for any terms that simplify. Harshram, do you see anything on the top and the bottom? Sorry, one more time. X minus 2's. I see one here and one here. Just going to use a different color. Oh well. That's exactly right. Those reduce down to 1. Alyssa, do you see anything else that we can reduce here? X minus 3. Here and here. Those are good. Now we're almost done. There's a couple things I can do still to make this a little bit cleaner. What do we see? The 10 and the 2 will reduce. That's exactly right. 2 goes into 10 5 times. So I can rewrite this. One of the students last period pointed out that we don't have to leave this as x plus 3 times x plus 3. And probably on the test they will write it as x plus 3 squared. Does that make sense to everybody? They don't cancel, but I can write those together. Be left with a 5 times x plus 1 on the bottom. Again, this is multiple choice. You're doing all that work. You're just then finding this one amongst the answers that they give you. All right, let's see. Let's try number, what did we do last time? 7 and 8 are good practice, but they're very similar to the last couple. I would like you guys to try 7 and 8 as homework. If you get stuck, again, use the area model on the ones with A values. Okay, so let's skip 7 and 8 for now, but I don't want you to cross them out like we did for 3 up there. I want you guys to try those if you have time. And instead, let's look on the back page. Let's look at number 9. Number 9. Does everybody see it's addition? So I have to have common denominators. But I already have common denominators. There's no extra steps here for that part. The bottoms already match. So I'm going to go straight to 4x minus 15 plus 3 over x squared plus 5x minus 24. So with this, 4x minus 15 plus 3, negative 15 plus 3, I can combine those. Negative 15 plus 3 is going to be negative 12. So 4x minus 12 over x squared plus 5x minus 24. So you get to the test, you're like, bam, done. But that's not one of the answers on the test. You need to factor this again and see if anything reduces. Does that make sense? Maybe it doesn't. Maybe that answer will be on the test. Or maybe you have to do that extra step. What goes into the top two? 4, right? Take that 4 out. 4 times x minus 3. On the bottom, are there two numbers that multiply to negative 24 and add up to 5? I think I heard somebody. Anybody else? Again, think through. It's funny how sometimes you'll miss it. You're like, oh, I can't find a, and then, oh yeah, there's that one other combination that makes 24. So go ahead and say it if you think you know what it is. 8 and 3. Does that make sense to everybody? X, we want it to be x plus 8 and x minus 3. That way when we multiply it out, we get that negative 24. Adds to 5x. Now we can see, oh yeah, x minus 3 is reduced to 1. And I'm left with 4 over x plus 8. Can I reduce the 4 and the 8? No. Again, right, the x plus 8 is locked in there. Put it in parentheses if you want to. That 8 cannot be reduced because it's a part of that addition along with the x. So here is my reduced answer. Number 10, I think you could do if you wanted to. Let's skip that one for now. I'm going to give you a little hint on number 11. Number 11, the bottoms almost match. When this happens, and it will probably happen, we seem to have a lot of these where they're so close, you can take a negative out of both terms to flip it around. So I would rewrite this, keep the first one, 6x over x minus 2. Take a negative 1 out here. So a negative 1 out, which would let us make that x become positive, the 2 become negative. 12 on the top would stay. And then I would move this negative up to the top. 6x over x minus 2 plus negative 12 over x minus 2. Could you all finish that one? It's like 2 more steps. Take 30 seconds, finish that one. We'll move on. Right, when you're done, you can check your work up here. Right? Should reduce very nicely down to a single number. But now let's look at 13. 13 does not have like denominators, and they are not close to being like denominators. So I'm going to have to make these two fractions have common denominators. And to do that, I am essentially going to multiply each one by what it's missing. This one, x plus 1. This one, x plus 4. That means this one needs an x plus 1. And if I'm multiplying the bottom by that, I need to multiply the top by it also, because this is one big 1 then. Over here, this one has the x plus 1, but it needs an x plus 4. Now, I can rewrite this. I'll have x plus 4 times 2 over, or you put the 2 in front, x plus 4 times x plus 1 minus, and you could move, we had talked about moving the minus sign up to the 3, right? You could rewrite this, make this a plus, negative 3 times x plus 1 all over x plus 4 times x plus 1. Oops, almost forgot the 1 there. Now they have like denominators. I can put this all together as a single fraction. Let's rewrite this a little bit. 2 times x plus 4 minus 3 times x plus 1 all over x plus 4 times x plus 1. No canceling yet because the top is all one big subtraction problem right now. So distributive property. 2 times x, 2x, 2 times 4 is 8. Negative 3 times x, negative 3x, negative 3 times 1, negative 3, all over x plus 4 times x plus 1. Now we can combine like terms. I've got a 2x minus 3x would be a negative 1x. 8 minus 3 would be positive 5 over x plus 4 times x plus 1. There's no reducing that. The top does not factor. We are done right there. That is my answer. Does that make sense to everybody? Let's do another one, or at least start another one. We don't have tons of time, so I'm going to get this one started for you. 15. 15 is a little bit easier. This x squared minus 9 factors into x plus 3 times x minus 3. So this one already has the x minus 3 that the other one did. So I just need to multiply this guy by x plus 3. So that would give us 4 times x plus 3 over x plus 3, x minus 3. And then normally it would be minus 3x minus 5 over x plus 3, x minus 3. But you might want to make this a plus right here and put the negative up on top. In parentheses to remind yourself that you're subtracting that whole thing. Put it all together, do the distributive property, combine like terms. I'm going to let you guys finish that one later. Okay? Does anyone have questions though right now about how you would finish that? Again, very similar to 13. Flip the page over. Let's look at 16. For 16, if you have multiple fractions and an equation, we can do that fraction busting, getting rid of the denominators by multiplying by the least common denominator, which in this case, the least common denominator would be x times x plus 2, right? I need an x plus 2, even though it's shared between those two. I need an x from this one. So I'm going to multiply every single term by that. 3 times x plus 2, which is all over x, minus 4 times x plus 2 over x plus 2 equals, there's an x here already, times x plus 2 all over x plus 2. And then I have lots of reducing, lots of simplifying. X is here, leaving me with just 3 times x plus 2. X plus 2 is reduced there. Left with just negative 4x. X plus 2 is reduced here. I'm left with just x times x, or x squared. No fractions. Once we've got that, no more fractions, we can do the distributive property. 3x, 3 times 2. Don't forget that times 3 times 2 makes 6. I would get everything on one side, get it equal to 0, factor, and solve. I'm going to give you a minute and a half here to finish that one. Combine any like terms, get everything on one side, factor, and solve. Combine those like terms, get it all equal to 0. Then factor this binomial that's left over. Should factor just like what we were doing before.
Like this. Oh yeah.
All right, so Alejandro, what did you do first here? You subtracted x squared? Okay, that'll work. I would have personally moved everything else over, even though that's a little bit more work. But the issue is now we're going to have a negative x squared. Not the end of the world. And then is everybody good? The 3x minus 4x be a negative 1x. And we'd have that plus 6 is equal to 0. So at least everything's on one side. It's equal to 0. If you end up with a negative x squared, I would either factor a negative out, multiply everything by negative 1, get rid of that negative on front of the x squared. So really, I would like to see x squared plus x minus 6 equals 0. Just because most of us are better at factoring this one than we are at this one. Both would work. But again, if you need to get rid of a negative, you can multiply everything by negative 1 or factor a negative 1 out. How does this factor, though? Caitlin Y, what do you think here? How can I factor x squared plus x minus 6? There we go. X plus 3, x minus 2. Not quite done yet, though. What are the actual answers? Not here today. Hi, May. What are the actual answers? Yep. Negative 3 and positive 2. Now, it says check for extraneous solutions. So I'm going to go back up here. My least common denominator, my denominator's here. X cannot be 0 or negative 2. Well, neither of those were the answers that I got, so I'm okay. Those are my two answers. I would recommend that you guys try 17 and 18 as well for homework. I'll come back through and tell you which ones I'm expecting you to do over the weekend. Let's jump down to 20. Number 20. Daniela can clean the kitchen in 12 minutes. Nick can clean the same kitchen in 16 minutes. Write an equation for the time t in minutes it would take them to clean the kitchen together. This one, again, those rate problems. 1 over the first person's rate plus 1 over the second person's rate. This is how much they got done in 1 minute, how much of the kitchen they get done in 1 minute. Added together gives you how much of the kitchen they get done together in 1 minute. So that's my function, just like what we did, or that's my equation, just like what we did earlier. I'm going to multiply both sides by the least common denominator to solve for t. So my least common denominator, 12 and 16, all right, 12 is 4 times 3. Could take that 4 apart into 2 and 2. 16 is 4 times 4, 2 and 2, 2 and 2. So really I need 4 2s and 1 3. And the t. Don't forget that t. So my least common denominator is 2 times 2 times 2 times 2. So 2, 4, 8, 16 times 3 is 48t. 48t. That 48t is what I'm going to multiply everything by. 1 over 12 plus 1 over 16 equals 1 over t. Multiply everything by 48t. Again, I can do this because it's an equation. I'm allowed to multiply both sides by whatever I want to. 12 goes into 48. 4 times, I get 4t. 16 goes into 48 3 times. T's cancel out there. Not the 48 though. 4t plus 3t equals 48. 4t plus 3t is 7t equals 48. Divide both sides by 7. 48 divided by 7. Get about 6.857. About 6.857, or really you could probably round it to about 6.9 minutes. Which again makes sense. In between half of Daniela's time and half of Nick's time. How do you guys feel about that word problem? Y'all remember doing ones like that? Some of us were still on the test, we're still struggling with coming up with that equation. The equation 1 over the first person's time, 1 over the second person's time equals 1 over the third person's time. So that gets us like 3/4 of the way here. On Monday, we'll go over the back page, the graphs. Okay? On Monday, we'll do the graphs along with Unit 5. Okay? We'll go over everything in Unit 5 on Monday. Make sure everybody's feeling pretty good there. Over the weekend, I want you guys to try 7 and 8. Probably, I mean, you could do 10. That would be nice and easy. 10 and 12. Those would be good ones to try. And then 17 and 18 here. So that gives you what? 6 problems? 1, 2, 3, 4, 5, 6. So try 7 and 8. 10 and 12. 17 and 18.